Good morning, and thanks for joining me today. My name is Jeff Weir. I'm a senior manager on the identity team. If you've ever visited our IAM forums, you've probably spoken with me. I'm known as Jeff W. And I got to tell you, this is the 5th time I've spoken at reInvent, the 3rd time I've talked about policies, and a little bit in awe about the number of people who turned out, and especially this room that they gave me. All right, guess it's popular. So before I get started, let me just give you a warning, some disclaimers that I kind of talk about. So if you didn't realize it, the following 60 minutes are essentially me going to be going through JSON documents, okay? If that doesn't excite you, and there is no way I would rather spend an hour at 11 a.m. on a Wednesday, but going through a bunch of policies, but if that doesn't excite you, it's not too late. There's a lot of other great sessions out there, and you won't you won't hurt my feelings. And really, I'm not kidding. It's going to be 60 minutes of policies. A full hour of squiggly brackets, square brackets, quotes, commas, and you're still here. So, all right, let's start becoming ninjas. So hopefully you're here because you want to learn more about securing your AWS resources. And specifically, I hope that everybody walks out of here with a deeper understanding of IAM permissions. Something like 70% of you are first-time reInvent attendees. So my presentation is kind of going to be, we're going to go from 0 to 60 really fast. I'm going to go through some of the basics of policies, go through some of the intermediate concepts. And then what I really want to do is pass on some of the things that I've learned. So in my nearly 5 years at Amazon, I try to carve out a little time each day, each week to look at the forums, look at our customer support tickets, and try to figure out where people are having trouble with policies. And then quite honestly, I try to solve those same policies myself to see if I can do it the way the customer is trying to do it, or to help them because they haven't gotten there. And over that time, I've picked up a lot of tips and tricks, and so I'm going to pass on some of the debugging, testing, and other policy foo that I've learned over those years. Now, as I mentioned, this is a session on policies, and I don't know why, but every year they give this to me, and I wonder who is going to come out and listen to me talk about policies for 60 minutes. So sort of my unwritten rule here is I'm going to try to keep you all awake, and the way that I'm going to do that is I'm going to try to show you, cram as many demonstrations as possible into the next 60 minutes. And because it's going to take me all the way to the hour, I'm just going to ask that if you have questions, and you will have questions because you're going to see things that probably won't make sense the first time you see it. But if you have questions, I just ask you to hold them to the end, and then I'll hang out for as long as they'll let me, and I'll be happy to answer your questions. So with that, let's get into the first demonstration. Now, this was an actual customer asked us to do this. They were having a problem with a support ticket, and it got all the way to the engineering team. And the engineers actually got stumped on this. They couldn't figure out how to do it. And it's a very simple concept, right? The idea is that I want my users to boot up EC2 instances, but to control costs, I only want them to be able to launch certain instance types. And specifically, back when this customer wanted to do it, they wanted to limit them to T1, T2, and M3 instances. So let's go through using the tools, and I'm going to show you how to create a managed policy, and we're going to attempt to limit starting an EC2 instance except for these 3 instance types. And then I'm going to attach that to a user and test it out. And so throughout my presentation, I'm going to assume 2 personas, okay? And I'm going to flip between Chrome, where I'm the administrator, making changes to policies, and I'm going to switch to Firefox, where I'm Bob. Bob is my user. I'm going to use Bob. I'm just going to be attaching policies to him and seeing what happens. So as the administrator here, I'm going to open up Bob. And he currently has no permissions. So I'm going to go ahead and I'm going to add permission. And I'm going to create a new policy. And I am going to use the policy generator. And the first thing I want to do is I'm going to grant an allow policy. And so I'm going to choose Amazon EC2. I'm going to grant access to all actions on all resources, and I'm going to add that statement. Now, the next thing I want to do is I'm going to deny. And once again, it's going to be for EC2. And in this case, I'm going to deny a specific action, and that action is the run instances action. This is the one where if you go and launch an EC2 instance, this is the API that's being called in the background. And once again, I'm going to put this for all resources, so nothing complicated so far. And I'm going to add a condition. Okay? Now, logically, I'm going to go in and I'm going to say, for that condition, I want string not like, instance type, T1, T2, M3 star. I'm going to add that condition. I'm going to add that statement. I'm going to click Next. I'll give this a very creative name. And then it generates the JSON for me. Now, I'm kind of anal retentive, so there's a few things that I always like to clean up. For example, if I have a list of single items, I don't need the square brackets, so I'll get rid of some of those. Clean out the SIDs because I don't need them. And then one of the things that you'll notice is the policy editor is a much more full-featured JSON editor. It's going to help you with the grammar and the policy syntax. And you can also choose to turn on and off some of the auto formatting for it. And so if I validate that, it's going to tell me that somewhere in there I introduced an error when I was cleaning it up. So if I go to line 9, it's expecting that I have a comma instead of quotes. And so if I put in the comma, validate it again, it's going to tell me that my policy is valid, and now it's a little bit easier to read. So I've granted access to all EC2 actions, and for this one action, I'm denying access for T1, T2, and M3. So I'm going to create that policy. Just refresh it here. And there's my policy, review, add permissions. And so now this is the policy that is attached to Bob. So I'm going to switch over to Bob, and I'm just going to refresh here. Now I can go, and let's test the fail case first, because I think that's interesting. I don't want Bob to be able to launch instances over a size. So let's take something like an M4 16XL. I definitely don't want him to do that. Review and launch. Yeah, I'll accept all the defaults. I acknowledge, launch instance. And voila, fail. So far, so good. Bob can't launch an instance that he hasn't been granted to. So I'm going to go back, and I'm going to edit the instance type, and now I'm going to choose something in the free tier, so the T2 micro. I'm going to go through the process again. I'll accept a bunch of these things. Acknowledge, launch, and I've also failed. So I think we would all agree that that's not very ninja-like, okay? It's not the desired result. And I show you this not because I want to discourage you or that I'm just a mean person, though I am really a mean person. I wanted to show you kind of what the first-time customer experience is, because everything you did seemed very logical. I went through the tools, I chose all the options, and I didn't get the desired result. And I promise you by the end of this presentation, I'm going to show you a very simple policy that actually succeeds for that use case. But in order to get there, we have to kind of start from the beginning. So the first 10, 15 minutes, what I'm going to do is walk you through some of the basics of the policy language. And so the first thing you have to know is this is how we authorize all of your requests to AWS. And there's really two facets to it. There's the part that as computer scientists or developers is pretty easy. That's the specification. Like JSON isn't that complicated. Understanding the syntax isn't that hard. That's sort of the science. The art is the enforcement. And that's really understanding how policies are evaluated, how the different services actually interpret those policies, right? So that's where we're going to focus most of the presentation today. So as we've seen, policies are nothing more than JSON formatted documents. They contain statements. Those statements have a principal or an actor and an actions or the set of APIs that you can access, and of course the resources that you want to access. And all of the policies follow what I call kind of a PARC model, the principal, action, resource, and condition. And before we get started into building some of these policies, I kind of want to walk you through and show you what each one of these look like. So the first one is the principal. The principal is an entity. It's the thing, the person, the user, the group, the role. This is what is allowed or denied access to a resource. And the way that you indicate all of these principles, or actually anything inside of Amazon, is through the Amazon resource name, or what I'm just going to call ARN for the rest of this presentation. Now, when you're using an IAM policy, you're usually attaching this to a user, a group, or a role. And when you're doing that, the principle is implicit. There's no reason to put it in the policy, because if it's attached to a user, you know that the user is the principal. But there are cases with resource-based policies, like a policy attached to an S3 bucket, where you're going to have to specify the principal. And so this is what some of them might look like. Let's say that you have a bunch of images or stuff that's in a bucket that you want to provide anonymous access to an informational website. You might use the anonymous users, which is just simply star.star. You might have to grant access to another AWS account. And this is actually a use case I'll go through later in the presentation. And there's two ways to do that. You can either put in the 12-digit account, or you can put in the full root ARN. Of course, you can use an IAM user, and that's what that looks like. Or if you're using something like Cognito, you might be using federated users, users that are logging in from Amazon or Google or Facebook. And then there's also the role. Roles are used for federation. They're used to launch EC2 instances. And then speaking of EC2, when you launch an EC2 instance with a role, and I hope you all are launching your instances with a role, you're actually delegating access to the EC2 service. And there's a principal for each of the AWS services, and that's what the EC2 one looks like. Now, if it's not obvious, I'm using fake account numbers for all of my slides. So if you're taking photos, and you really don't need to really take photos if you want, I'll email you these slides if you want. You just need to replace these with your actual 12-digit account number. Now, action is what you want to do, right? And there are literally thousands of actions. So this is where the documentation is going to become your best friend. Either that, or from the policy generator or the policy simulator, you can get a list of all the actions, or what sometimes I'll call APIs, because there's almost a one-to-one relationship between action and APIs. Now, statements need to include an action or a not action. And so here, I'm going to show you what some of those actions look like. And so here's 3 for EC2, IAM, and S3. Here's a couple for SQS. Now, most of the time when you're building policies, it's actually probably going to be a list of APIs. And the way that you show those in a policy is you encapsulate that list in square brackets. And then you can also use wildcards. So down here, you can use an asterisk, which is a multi-character wildcard, or you can use a question mark, which is a single-character wildcard. And so for the example down here where I have IAM star access key star, it's actually a shorthand way of granting access to the create, delete, list, and update APIs. So you wouldn't have to list them all out. One of the things you'll learn as you're creating policies is there's a finite amount of space that you can use for a policy for anybody who's hit that limit. And this is a nice shortcut way to keep your policies nice and condensed. Now, I mentioned quickly that you have to have an action or a not action. And I find that a lot of people are confused by what I mean by not action, or simply when you put a not in front of it. So I want to take a look at an example here. And what you have to remember about not action is it's allowing you to specify an exception or an exclusion to a list of actions. And this is also going to help you to create, what I think are smaller and easier to understand policies. But let's look at an example just so that you understand the difference. So here I have a policy that it's an allow policy, and I have a not action of IAM star on all resources. Alternatively, I could create a similar policy where I grant all APIs, and then I have a second statement where I deny IAM star. So, question for the audience. Is there a difference? Anyone think there's a difference? Besides one is longer than the other? Yeah? This gentleman is correct. So, I'll just go over where the difference is, and he nailed it. This one over here is not a deny. It's an exclusion. So technically speaking, if another policy is attached to this user, or the user is erroneously added to an administrative group, they're going to get access to the IAM APIs. However, on this side, you have an explicit deny. And an explicit deny always trumps an allow. So even if somebody mistakenly puts this into an administrative group that would grant access to IAM, this user would always be denied. And so that's probably one of the common mistakes that people make, is they think that when they're using a not action, it's actually resulting in as a deny. Only if there's not another policy attached would it act as a deny. Okay, the resource is the thing, right? The object or objects that you're trying to request. And of course, statements are going to have a resource or a not resource. And so here's a few examples of common resources for an S3 bucket, an SQSQ. I like to show the Dynamo ones because they're really long, and so there's a couple of them. And then the EC2 one is one that we're going to use later on in the presentation, where this actually grants access to every EC2 instance in US East 1, right? So that's our Virginia region. The last part of the PARC model is a condition. And conditions can be a little bit tricky to understand if it's the first time you looked at them. So I like to show these with an example. Now, a policy can have multiple conditions. And with a condition, you can have one or more keys. So here I have the current time key, and I have the source IP key. And then when you have a key, you can have multiple variables or values. So the way that these are evaluated, like between the different keys for current time, and source IP, those are treated as a logical AND. And then as we evaluate the values for an individual key, those are treated as a logical OR. So the way that you end up interpreting this condition is if the time is after 11 a.m., universal time code, on November 30th, 2016, and the time is before 3 p.m., 11/30/2016, and the request comes from either of these two CIDR blocks, then the statement that this condition is attached to will evaluate to true. And I know that's crystal clear, and nobody has any questions about it, so I'm going to move on. I'll show you some other policies, and I'll go through the conditions. So I'll keep beating that in until it makes a lot of sense. So those are the basics. So let's get into some of the more intermediary concepts. So thus far, we've looked at literals in policies. And there's a way to enter in variables into your policy that make managing policies a lot easier. One of the examples I'll typically go through is, what if I wanted to create a home directory in an S3 bucket where I have a path for each of my IAM users. And if you have a couple IAM users, it's not that hard to hard code a path, for Bob, Craig, Sally, Jeff, whatever. But you have hundreds or thousands of users, that can be a real pain. And so one of the things you can do is any of those keys that I just showed in a condition can be used as a variable. And so we looked at the source IP and the current time keys, but there's also keys for username, user ID, principal type. If you're using any type of federation via Cognito, or maybe you're using SAML, the security assertion markup language, there's a set of provider-specific keys that you can use as variables in your policies. And so I'll show you a few examples of this, and both these use cases here are demonstrations that I'll show in a minute. And so this is the anatomy of a policy with a variable. The first thing I'm going to point out, and I will pause here, is that the version is required. If you don't put in this version, we're going to treat all of those variables as literal values. And I can't tell you how many times I've made that mistake, where I left the version out, I'm trying to test this, and I've lost hours, maybe days of my life because I left that simple version out. And so I'm going to beat that into everyone's brains because you don't want to be like me. You could use a variable as part of a condition. You can use a variable as part of a resource ARN. And you'll notice here, all we do to create a variable is you take the key, you encapsulate it in squiggly brackets, and you put a $sign in front of it. And so it can be part of here I have it part of the prefix in the condition. I also have it as part of the resource ARN. And what this policy does here is it grants a user access to a home directory in S3 that can be accessed programmatically. And I say programmatically because you're going to need a whole set of additional permissions if you want to be able to use the S3 console. So the next thing I want to go through is policy enforcement. This is how we literally evaluate the policies when you make a request. So when you make a request against an AWS resource, by default, we assume that you're denied access. And what we do is we gather up all the policies that are associated with the user, associated with the resource, and the action that you're trying to take. And we go through and we evaluate all those policies. Now, if anywhere in all of those policies is a deny, it doesn't matter if the rest of the policies provide and allow, we deny access to that request. Then we go through and we look and say, okay, was there an allow? There's no deny, so let's look. Is there an allow? Yes, there's an allow, so we'll go ahead and we'll grant you access to that resource. If there's no deny, if there's no allow, we kind of start back at the beginning where we started, and we deny you access to the resource. So that's a pretty straightforward process. Okay, so hopefully that gives kind of the basics of what IAM and policies are. I want to go ahead and start looking at some more examples. And the first one that I want to do is creating a home directory using S3. So the goal here is that I have a set of IAM users, and I have a single bucket, right? And I want to share that bucket amongst those users, but I want to have a path, a folder, a prefix in S3 terms that limits the access to my individual users. So specifically, I'm going to go ahead and create a policy that uses policy variables, and I'm going to enable all of my users to list buckets in the S3 console, and I'm also going to limit those users to accessing only specific folders within that bucket. And so to do that, I'm going to go back, and the first thing I want to do is remove these permissions from Bob. And I want to just show you, currently, Bob has no access to the S3 console, so he's currently getting an access denied. Now, if I go in here, I'm going to add a user to a group. So just like any of those good cooking shows, I got already thing cooking in the kitchen for time. And so I've created a group for the reInvent S3 home folder. I'm going to add him to that. And what that does is it gives him this lovely policy. And I know you can't see it, so I'm going to go through this in PowerPoint in the PowerPoint presentation, so don't worry about it if it's not clear. But I'm just showing you that this is all real. And now if I switch back over as Bob and I refresh, Firefox does its thing. You're going to notice that Bob can see all the buckets. Now, I'll pause here for a minute because this is on purpose. One of the things you have to understand about the tools is they make some assumptions. So when you go to the S3 console, there's a set of APIs that are called by default. And if you don't grant access to those APIs, you're just not going to get past step one. And so one of the things that the users have to be able to do is see all the buckets. Now, he doesn't have access to them. He's going to get access denied no matter where he clicks on them, but he will be able to see them. The only bucket that he can get into is the demo bucket. Of course, he can't get into the finance folder. He can only get into the home folder. And in here, he can't access other users' folders. He can't even access other users who have a similar name. The only thing he can do is go into his home folder for Bob, where he keeps images of my daughter. So, yeah, moving on. Let's assume that that's not some weird thing. Bob's a family friend, and he likes to keep images of my family in his folder. So how did I go about doing that? Let's take a look at the policy. So as I mentioned before, the first thing you have to do is set the version, because I'm going to use variables in this policy. And there's a set of APIs, as I mentioned, that you need to access the console. So specifically, you have to grant access to S3, list all my buckets, and S3 get bucket location. Now, if you don't want your users to see all your buckets, there's a lot of third-party tools out there. But in this case, you won't be using the S3 console. So this is what you need to just view all those buckets. And then specifically, I want him to have access to an individual bucket. And to do that, I grant access to the S3 list bucket API for the yarn for my bucket. And here I'm using a string equals that allows him to see prefixes as long as they're null or they're home. And then the console uses a default delimiter of /, so I put that in the policy as well. Now we want him to be able to see inside of that bucket, specifically within his home folder. So once again, I'm granting access to the same API. This is list bucket. Okay, but I have to create a separate statement, even though it's using the same resource, because in this case, I'm using string like. So the difference here is this is string equals, and this one is string like. And that's because I have a variable, which is going to be dynamically resolved at runtime, and I'm using an asterisk because I don't know what objects are going to be in there. And so I can't use a string equals, I have to use a string like. Now, I have to have one more statement because I need to be able to manipulate objects in that folder. So when I clicked on that image, it was allowing me to do a get object. Now, interestingly enough here, when you use a list object, the resource target has to be the bucket. And if you've ever programmed using S3, you know that. When you call something like getObject or putObject or deleteObject, you're not using a target of a bucket. You're actually using the full path of the object. And so here, I have to grant access to the root of the folder using a variable and potentially any subfolders. So I didn't have any subfolders in my example here, but you can imagine Bob had built out a folder tree underneath. And so this is the policy that you would need to do in order to grant access to that folder. So another common scenario that people talk to me about is they have these projects. And administrators, we're busy people. We don't have time to creating users and setting permissions all day, right? So you want to be able to delegate that authority to a project owner, but you don't want them to have full admin rights. So this is something we call the limited IAM administrator. We actually have a security blog post, and I'll send you, there's links at the end of the presentation if you want to read more about this. But the idea is that I create an IAM administrator, and they can use the IAM console, and they can manage users, and they can create users, but they're only able to attach certain policies. And so in this example here, I'm going to create a user. That user is going to be Bob. And Bob is going to have the ability to create users, but only attach this Amazon DynamoDB full access and the S3 bucket policy, sorry, the S3 policy that I had used on Bob. And so I'll switch now, and I'll go in. And once again, I'll strip Bob of all of his rights. I'm going to add him to another group. This time it will be the reInvent limited IAM admin group. And one of the things I'm going to show you here is you can have multiple policies attached to a group. And so there's two policies that I have here. One, which is kind of a generic policy that I created that gave access to a user to access the management console and sort of manage themselves. So maybe they want to go in and rotate their secrets or something. So I'm leveraging that policy. And then the other policy here is specifically what limits the user. So the user can go in and create a user, and they can attach policies, but there's certain policies in here that they only have access to. And so now that I've added Bob to this group, I can go over to Bob. Let's get out of that. Go to IAM. And you'll notice you'll get some error messages because I haven't given him full rights to IAM, right? But he can go into the users. He can see a list of the users. He can create a user. Let's say let's create a user Craig. And he can access the management console. Let's give him a password. I don't know what I just typed, so let me retype that. It wasn't password. And then click Next. And here I'm going to attach some permissions. So reInvent, what did I do? It was the S3 home folder I gave him access to. And the other one was DynamoDB, DynamoDB. And I think it was the full access one. We'll find out if I did it right in a minute. So click Review, Create User. And I have, in fact, created a user, Craig. Oops. Let me go back here, look at my users. And one of the things I just want to point out is, I can't go and elevate privilege. So if I try to go in and add permissions, and I try to add, Craig to the admin group, so let's give him full admin access. See, Bob's going to get an access denied. So he can't elevate privilege. He can only do work within the sandbox that I've done. And so he's created Craig. Now, this is where I'm going to have to actually log out. So I'll sign out. I'll sign back in. And this time I'll come in as Craig. Fingers crossed that I got the password right. And Craig can do a few things. So we gave him access to Dynamo. We gave him access to S3. We didn't give him access to EC2, so that might be interesting to look at. So I'll go to Dynamo, because that loaded first, and I'll go to tables. And in here I have a game stores table. And he can go in and he can look at all the items, and there's users named Chuck, Norris, Bruce, and Lee. These are my ninjas. Okay, they're not really ninjas, but it's the best I could come up with. So he has full access there. And then if I go to the EC2 console, you can see he's going to get a bunch of error messages because he doesn't have access to anything there. If I go to S3, he's going to have the same permissions as Bob, but just to kind of prove it, if he goes into the demo folder, goes into home, he can't get into Bob's folder. He can only get into Craig's folder, where there is literally nothing to see. And there is literally nothing to see. So it just kind of proves that if you have these project administrators, you can go in and they can be fully in charge of managing those projects, and you as the system administrator don't have to get involved in that. And so let me log out again, just set up our next demo. Bear with me. Okay, so how did I do that? So as I mentioned, I have two policies attached to the group. The first one is just this general policy that I give. I kind of call it the self-manage policy because it allows me to go in and look at all the users. And if I want my users to be able to go in and change their password, the action is get login profile. Why we chose get login profile instead of set password, I don't know. But if you want to be able to set your password, that's the API you're going to need. You want to be able to list the groups for my user. Maybe I want to be able to list the keys for myself. And so this would allow you to self-manage. Now, I'm kind of just taking advantage of that policy because it also allows the user into the management console. Now, I need to be able to create users and attach permissions. So once again, I'm not using a variable in this one. I don't know why I put that. Well, I put the version in there just because it's good hygiene. But here's the list of all the APIs that you would need in terms of creating a user, creating a login profile, being able to list their policies, and do everything that I showed. And then here's the little piece of trickery. Kind of this is the pro tip. Is if you want to limit the user to attaching specific managed policies, you're going to take advantage of the IAM attach user policy and the IAM detach user policy. And specifically here is where you put in the ARNs, because each of these policies now have an Amazon resource name for them. You just list all the policies that you want the user to be able to add or remove to the users. And that's it. That's how you create a limited admin. Now, lots of customers these days are using multiple AWS accounts. In fact, are there anybody in here using more than one AWS account? Okay, great. All right. So you might actually get value out of this policy then. So when you have multiple accounts, let's say you have a developer account and you have a production account. One of the nice things that we introduced some time ago is that from the management console, you can take advantage of this thing called switch role. Right? And so you create an IAM role, and then you switch between the two. And by default, when you create one of these roles, it has an access policy, what can the role do, and it has a trust policy, who does it trust. And by default, when it generates it, it sets a trust at the root level, so it trusts the entire account. But you can modify that, you can change it, and you can scope it down. And in fact, you can use IAM users, or you can use federated users. And a lot of people don't know how to specify a federated user because they've never seen the STS ARNs before. And so I'm going to show you this demonstration, but because cross-account access is typically a new concept for most people, I'm going to use a diagram. So imagine I have a developer account, and I have a developer, and creatively his name is Bob, and Bob wants to access the production account. In my production account, I have a role creatively named my role, and this role grants some amount of permission. So I didn't have room, so I just said actions over here. And that's the access policy. And then you have the trust policy. This is who can assume the role. And by default, it's going to give you something like this. It's trusting everybody in this root account. Now, it's not really trusting everybody because inside of the developer account, a principal needs to have been granted access to assume that role. So I have Bob, and Bob has a policy that allows him to call assume role on this role. And this is what you have to do to set up the switch console, right? So Bob logs in as Bob into the management console, and then he goes and he uses this feature called switch. And when he does that, what happens behind the scenes is it assumes a role, and then it logs him in as a federated user, if you will. And his identity actually in the system changes. At that point, he looks like this. So it's an STS ARN where it has the assumed role, my role, and Bob. And so if the policies were too small to see, this is what a trust policy looks like by default. And granting access to everybody in another account, that's not so ninja-like. But you can change that to an IAM user, right, using the IAM principal ARN that we looked at. Or you can change that to a temporary credential using STS. And, of course, you can even mix and match. So let's go ahead and see what that looks like. Now, I'm using IE because I need a third browser, and otherwise I wouldn't. And here is my role, and you can see here's the AWS account. Here's the name of the role. And what you do to add this is you go to switch role, and this is where you would add in the account, the role, and the display name. Now, of course, I've already done this. So if I go over here, once again, I'm just going to remove Bob from this group. And I'm going to add him to a group. And I'll use the cross-account access. I used really good names. I'm going to add permissions here. And then once again, there's a single policy here, and it's a very simple one. It's the same one we saw on the slide that allows him to assume that role. Now, if I go over here in, let's look at what don't I have access to. I don't think I have access to EC2 right now. So if I go in here, oh wait, I am the admin, sorry. If I go over here as Bob, and I look, I'm going to see a bunch of access denied. But what I've done over here in the role, sorry, I'm switching between browsers. So now I'm in the developer account, or the production account. And here's the role. And the permissions that I've granted is access to the read-only policies. So this gives me access to every immutable API inside of AWS. And then I have the trust policy. And you can see down here I have the two trusted entities down here, right? But the way you do is you edit this, and it's just another policy document. And so I can go in here and I can add to the list of users that I want to actually delegate access to the account. So I've already done this. I've delegated it to Bob. I've delegated it to this federated user, which you haven't realized, but in the admin account, I've been logged in as a federated user the whole time. And if I go in as Bob, Bob has no access to IAM in this account. But when I go and I switch, so you just get it from the drop down here, I'm now going to switch to that account. You can see, and now I have read access. And so this is how I can switch back and forth. I can go back. And of course, just to prove it, here I am the administrator. And you can see I have this weird looking name up here because I've logged in as a federated user. But I can also switch to that account, where I actually have a lot less privileges because I only have read-only access here. But that's how you switch back and forth, and that's how you lock it down to just specific users or specific federated users. Okay. We got about 20 minutes left, and this is my favorite topic, because this is where everybody struggles. So let's talk about resource level permissions with EC2. So if you've been with us for a while, you probably remembered a time when policies, for EC2 policies applied to all resources. And the good news is now for a set of actions and resources, you can set permissions per resource. So the types of things you can do is you can limit a user from starting, stopping, or terminating a particular instance or set of instances. And so just to give you an idea of how this looked, this is what people created policies maybe about 4 years ago. And yeah, it's not very ninja-like because this allows a user to terminate any instance in any region anywhere. Doesn't matter if they have access. This is what they would need if they needed terminate access. And so we improved upon that. This is using the new longer instance IDs. You probably got an email about that. And this here says you can terminate an instance, but only if it's a specific instance. Now, that's probably not practical. So, maybe what you want to do is grant them access to terminate instances, but maybe only in a certain region. So these are all the instances in US East. But probably even better is tagging those instances. So I could tag an instance as dev, as production, or tag it as a specific owner. And now I can grant this policy to somebody and it'd say, well, you can terminate an instance, any instance in US East 1, as long as it's tagged with the developer tag. And so this makes writing policies for EC2 a whole lot more powerful. Now, what supports EC2 resource level permissions? EC2 has a lot of APIs. EC2 has a lot of resources, and they don't fit on a slide. So I'm giving you an example of some of the resources and some of the actions that you can use. You cannot use all resources, and you cannot use all actions. And quite honestly, this is where the documentation becomes your friend. I'm pretty good with policies, but when I'm doing something with EC2, I have two monitors, one for the docs, one for my policy editor, and I literally have to go back and forth, and I wish I had a better answer for you, but that's kind of the ninja way of doing it today. And so let's take a look at creating a policy using EC2 resource level permissions. And so the first one I want to show you is how I might limit a user from starting, stopping, or terminating an instance unless the instance is owned by that user. And the way that I'm going to do that is I have a number of EC2 instances, and they're all tagged with an owner tag. And I have a policy that's going to grant a user access to the EC2 console so they can go in and see it. And I have a policy that's going to limit what they can do with those instances based on the owner tag. So I'll go back in as the admin, and I'm going to select Bob. And once again, I am going to remove him from this group. And I'm going to add him to another group. And this one is going to be the reInvent EC2 owner group. And once again, he's got two sets of permissions here. Now, this first one is the Amazon EC2 read-only access. And this is a managed policy that AWS provides. So there's nothing you need to do to create this one. You just attach it. And if EC2 adds another API, it'll show up in this list. And so this will give him read access to the EC2 console. And then here's my policy that limits what he can do with the instances. And it's not that complicated. And like the other policies, I'll show you in PowerPoint so a human can read them. And now if I go over here as Bob, I'm going to open up EC2. I'm going to go to my running instances. And I only have two here, and they're both stopped. And one of the things I'll show, because I'm surprised how many people haven't played with this, but I have this owner column. And the way that you add this is, as you have tags, you can show and hide that owner column. So, little tip there. And for Bob, this one is tagged as owner Bob, so he can go in here and he can start that instance. In a few moments, that'll actually be running. But this is an instance owned by me, so I don't want Bob mucking with my instance. So I don't want him to, go in here and try to terminate it. But he'll try to terminate it, and then he'll get this lovely error message. And I'll show you what this error message actually says, because I can read it, but probably, most of you don't know what that says right now. So I'm going to cancel that. And if this is running, I can actually show you how Bob can go in, and he can even stop that instance as well. And this policy is pretty straightforward. So let me walk you through it. There's two policies. And as I mentioned, the first one, this is just the AWS managed policy called Amazon EC2 read-only access. These are all the APIs you would need if you went into the management console and you needed to view something. So specifically, all the EC2, all the ELB, CloudWatch, and auto-scaling APIs. And so you have access to all the describe and all the list. If you didn't want them to see something, you could create your own policy and you could cut back. But as a shortcut, this is probably the easiest way to give access to the console. Now, more interestingly is the policy that locks down access to EC2. And so like the other policies that use a variable, you got to make sure that you put the version in there, right? And then I have this condition. Remember that condition I had, and I was trying to explain it? So this is a pretty straightforward condition, just doing string equals. And this is what you do if you have a tag. So this is what it looks like when you put an owner tag. And I'm going to leverage variables here that resolve to Bob, Jeff, or whoever is a user in my account. And as long as I have this specific key and this value match in there, the user is going to be able to call any 4 of these APIs. Okay. So remember where we started, right? We wanted to limit a user from starting an instance unless the instance was a T1, a T2, or an M3, and I had an epic failure. Let's go ahead and try to do that one again. So same rules apply, except this time I'm going to use a manage policy that actually limits starting EC2 instances to those specific instance types. And I'm just going to simply attach that policy to Bob and go on. And so let me switch back over here. And I'm going to remove them from the group one more time. And this time I'm just going to add a policy. And let's see, reinvent. I have this verbose instance type policy, so I'm going to go ahead and attach that. And now Bob has access, so I'm going to go back here, refresh, and I want to launch an instance. So we'll test the fail case, right, because we want to make sure that we're limiting him. So I'll just prove this actually works. I'll go through and accept a bunch of the defaults. Yes. And of course, I get a fail message. So this is good. What I'm going to do is I'm going to copy this into my clipboard because I want to show you in a minute how you actually get something useful out of that. But I'm going to go back. Did I actually copy it? I don't know. Yeah, there we go. I'm going to go back, and this time I'm going to change it to the T2 because that was the one that we wanted to allow, right? I'm going to review and launch. Yes, next, launch, check, cross fingers, and voila, we're able to launch. And just to prove it, you can see that it's actually starting up there. And so that's how you go about actually creating a policy that does it. Now, what does that policy look like? It's a little bit more complicated. And so in this one, I use 3 statements, and I'm going to walk through them because these are a little bit more complicated than others that I've shown. So here is something that includes all services and actions that you want to exclude. And so this is important. I'm giving you access to everything in AWS unless it's an IAM API or EC2 instances. So this statement right here, it says you can have S3, it says that you can have Dynamo, everything. So if you want to lock it down, you actually have to put a list of APIs or services that you don't want them to have access to. Now here's another interesting one. This is using a not resource. And so what I'm saying here is you have access to the EC2 run instance for every resource unless it's actually an instance. Because when you launch an instance, you need a volume, you need access to the key pair, you need the security group, and so this grants access to everything that is not an instance. And then this last piece here is where we grant access to the run instance for the instances that are in US East 2 or EU West 1, as long as those instance types are T1, T2, and M3. Now it's kind of complicated, so I think we can make it even easier. And the way we do that is we take advantage of a very little known language thing that we have in the policy language called if exists. So the reason that first time I went through it failed is I was testing for a condition on a resource where that key doesn't exist. And if I test for a non-existent key, we actually evaluate that as an access denied. And so that's why that policy didn't pass the first time we went through. But you can append an if exists to any operator except for the null condition. And so, for example, here I can turn the string like if exists. And what this allows you to do is essentially create policies that don't care. If the key is there, we'll enforce the condition check. If the key isn't there because it doesn't exist, we'll simply ignore it. And so what we're able to do is to create a much tighter policy. And so this one here grants access to only EC2 APIs. It gives them access to all of them, so I don't have to worry about excluding IAM or anything else. And then here, I deny access to EC2 run instance for any instance in any region if the string not like if exists an instance type of T1, T2, or T3. And I don't have to add in any permissions. I don't have to make any other changes. And this is actually the policy that I gave to the customer to solve their use case. And so you can see it's not possible. It's really not possible to create that unless you go through and you understand how all the services do it. OK, so that sounds great. What if I get stuck? Can you call me? You can't call me. You could get on the forums, though, you know, I don't have a really good SLA on my response times to those. So let's look at some of the magic, if you will, of testing and debugging. So the first tool we have, and we've looked at this kind of extensively, is the policy editor, right? And this is going to give you basics, JSON editing, policy grammar errors, right? It's going to fix some of the syntactical issues you may encounter. Now, another tool that we have is the policy simulator. And just due to time, I won't have a chance to actually pull up the policy simulator and walk it through with you. But you can think of the policy simulator as kind of a sandbox where you can test your policies, or you can author completely new policies, and then you run them through the simulator, and it'll tell you if you're actually granting or denying access. Now, full disclaimer, it's not 100% perfect, but it is a tool that you can use to kind of get part of the way. If you really want to test a policy, at some point you're going to have to put it in one of your AWS accounts and test it. Now, EC2 has this authorization message, and it looks a little something like that. And if you know how to, you can literally pull some gold out of that message. Specifically, you can find out if the action was denied because it was an explicit deny, or whether there was whether they were allowed, right? You can find the principle, the action, the resource, the values that they were trying to do. And you need to use this little-known API called the decode authorization message. And so if you have access, or you've been granted access to call that, you can go in and decode that message. So let's take a look at how we can decode that message. And this is going to help us, if you were building that policy, and this is something that I did as I was going through building the policy, I was decoding the message to figure out what I was doing wrong. And so what I'm going to do is I've already tried to call an EC2 action, and I've already captured that to the clipboard so that I have it. And then the only way to decode this is really using the API or the CLI, and it's got I don't know why, it's got a bunch of like junk around it that you got to remove. And so I'll show you how I do that. And so I have to do this from the CLI, and I created kind of a Windows batch file to do this. So the first thing I'll do is I'll show you my ugly one. And this is just calling AWS CLI. I have a profile for reInvent. It's calling an STS API. That's decode authorization message. And then you pass in the encoded message, which I'll pass through the CLI. And then I pipe it out to a text file, and then I launch it in Notepad. So let me just show you what this one looks like. Now, it comes out something like this, which isn't all that human readable. And one of the things you need to know is you'll have to go and delete this, and you'll have to go in here, and you'll have to delete this. And then you'll see it puts a / in front of all this. So I don't like having to do that, so I've created a more advanced batch file that cleans it all up for me. And now you get something like this. And I can take this, which is better, but still not all that human readable, and I can drop it into my favorite JSON tool. And now I get something that's human readable. And let me see if I can bump that up a little bit. And so here you could see that I wasn't allowed, I wasn't explicitly denied, but I still had some failures. And if I go through, I can see that it was Bob, and I can see where he was trying to launch the instance, and I can scroll down, and then eventually, to get to the punchline, I see that there was a value of M16 extra large, which I knew he shouldn't be able to do, but this is where it ends up failing. But unless you know how to decode that message, you're never going to be able to find that information. And so with that, I want to congratulate you. You're all now certified policy ninjas.